Welcome to Get Your FRQ On. This question is from 2010. It's Form B, question 6, and it is not calculator active. In the question stem, we've got two particles moving along the x-axis for values of t between 0 and 6. The position of particle p at time t is given by a function p of t equals 2 cosine pi fourths t, while the position of particle r at time t is given by a function r of t equals t cubed minus 6t squared plus 9t plus 3. In part A of this question, we are asked to find all values of t between 0 and 6, such that the particle r is moving to the right. We know that particle r will be moving to the right when its velocity is positive, and we can use the derivative of r of t to determine when the velocity of particle r will be positive. R prime of t is greater than 0 implies that 3t squared minus 12t plus 9 is greater than 0. And 3t squared minus 12t plus 9 is greater than 0 implies that 3 times t minus 1 times t minus 3 is greater than 0. 3 times t minus 1 times t minus 3 is greater than 0 implies that t is between 0 and 1 or t is between 3 and 6. Therefore, we can conclude that particle r is moving to the right when t is between 0 and 1 and when t is between 3 and 6. In part B of this question, we are given the interval from 0 to 6, and we are asked to find all values of t such that the two particles are traveling in opposite directions. The particles will be moving in opposite directions when their velocities have different signs. Given the rule for p of t, we can apply the chain rule and determine that p prime of t is negative pi over 2 times the sine of pi fourths t. P prime of t will equal 0 implies that t is equal to either 0 or 4. P prime of t is less than 0 implies that t is between 0 and 4, and p prime of t is greater than 0 implies that t is between 4 and 6. From our work in this part and from our work in part A, we can conclude that the particles will be moving in opposite directions on the intervals from 0 to 1 and from 3 to 4. In part C of this question, we are asked to find the acceleration of particle p at t equals 3 and determine if that particle is speeding up or slowing down at that time and provide the reasoning. So we can find the acceleration of particle p at t equals 3 by finding the second derivative of its position function. P double prime of t is negative pi squared over 8 times cosine of pi fourths t. Evaluating this at 3, p double prime of 3 is negative pi squared over 8 times the cosine of 3 pi fourths, which is going to be negative pi squared over 8 times negative root 2 over 2. That product is going to be positive since both factors are less than 0. And based on our work in part B of this question, we know that p prime of 3 is negative. So based on these two pieces of information, we can conclude that particle p is slowing down at t equals 3. In part D of this question, we are asked to find an expression for the average distance between the two particles on the closed interval from 1 to 3. So the actual distance between these two particles at any given time t would be given by the expression the absolute value of p of t minus r of t. So the average value of this distance would then be given by the integral expression 1/2 the integral from 1 to 3 of the absolute value of P of t minus R of t dt. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.